For the problem we just analyzed, the Gauss Seidel iteration is performed in the following way. We start with the first equation and express u11, the first variable, or the first unknown variable, by the other variables, like this. So next we take the second equation and express the second unknown variable by the other variables, like we have done here. Next, we take the third equation and express the third unknown variable u12 by the others. And finally, we take the fourth equation and express the fourth unknown variable by the others. So when we have done this, we just make some visual diagonal here, and above this diagonal we index all the unknown variables with 1. The first with 1, and on below this diagonal we index all unknown variables by 2. Also these variables on the left side of the equation. So what are we doing then? We start with some initial value. We recall that in the problem, just take a look on it, we have some boundary values here. U equal 100 here, 100 here, 100 there, and u is equal to 0 here. And we have a feeling that the temperature in the interior points are closer to 100 than to 0 in most of them. So let's just start with putting the unknown, the initial value equal to 100 in the starting point. So if we put u21 equal to 100 here, u12 equal to 100, u22 equal to 100 on above the diagonal, then we can start computing this value. So then we get u11, which is index 2 here. So then we find the value of u112. And this value we can now transfer to this value and this value, and all other places where it's used. In this case, it's only used in these two, on these two places. When we have done this, we are able to compute the value of u212. So then we find that this value is equal to this plus this plus this. So when we have computed this value, we can now insert this value into this, and we do the same again. u12 is equal to this plus this, which is known, plus this, and finally we get u22 index 2, and we know all these values. So now we have completed the first iteration. All these values now we can put on above the diagonal again. We can now, instead of indexing with 1 here, we replace 1 in the index by 2, and we replace this index 2 on below the diagonal with 3. And we do exactly as we did in the previous round. So doing this iteratively, it's possible to show that the solution of all these 4 parameters will converge to the exact solution. And in fact, it's this convergence is rather fast. Why are we doing this instead of using the standard way with finding the inverse of the matrix and so on? The reason for this is that finding the inverse is much more advanced, especially when the matrix is very large. So in this case, we just have 4 equations and 4 variables, unknown variables in usual numerical methods. We have very many variables, and then it's time consuming to invert the matrix. So this method is often a good method for solving these type of problems.